In the last example, the variable was in the numerator, which made the problem work out pretty easily. Another possibility is that the x shows up in the denominator. Let's take a look at an example where that happens. So there's my right angle. I'm going to say that the angle I'm interested in is right there, 25 degrees. Suppose that we don't know the length of this side, but we know that the length of this side is 10 feet. In this case, let's label the sides that we're working with. First of all, across from the right angle is always the hypotenuse. And in this case, if this is my angle, then this is an adjacent side. Let's try to remember which of the trigonometric ratios uses an adjacent and a hypotenuse. To help me remember that, I'm going to look at SOHCAHTOA. Which of these uses an adjacent and a hypotenuse? Let's see. Well, this one does not use a hypotenuse, so it's not the tangent. This one does not use an adjacent, so it's not the sine. It looks like this one uses an adjacent and a hypotenuse, so it is the cosine. Let's set that up then. So the cosine of 25 degrees is equal to the adjacent over the hypotenuse. So in this example, the x is in the denominator. We still want to move that denominator out of there, so I'm going to multiply both sides by x in this case. The x's cancel there, and I have x times the cosine of 25 is equal to 10. We still have not solved for x, we have to solve for x. So to solve for x, I need to get rid of this cosine of 25. Since that's x times the cosine of 25, the way to remove it is by dividing. Dividing both sides by the cosine of 25. These cosines of 25 cancel out, and we have x equals 10 over the cosine of 25. You could type that in the calculator to try to get the answer to the nearest tenth.